evangelist. The fancy way of putting it, and he's going to provide a little talk for us on why code is why code quality is so important and continuous integration. So if you could put your hands together for Gareth Burns.
Thanks very much. I'm using my magic mouse, so hopefully it will actually work. Yes, it does. Brilliant. Cool. I'm Gareth Burns. Connor, thanks for inviting me here tonight. It's great to be able to talk to you all. As you can tell, I'm not from around here, naturally. So hopefully you can all understand my accent, but I am Head of Development and Build for SQS globally. I work here in Belfast. Belfast, we have our called GTSC, which is our Global Technical Service Centre. And all our real technical services come from essentially Belfast. We support the globe, essentially. So SQS, in case you've never heard of them, are the world's largest independent testing consultancy. Okay? So we have offices, we're basically kind of federalised, so we're run from Germany. We started there in the 80s, but we have offices all over Europe, India, South Africa, the States, you name it, we've got offices there. And we do a lot of work with a lot of different clients in different domains. But my background is not in testing at all. I am not a tester. I don't do testing, not in a kind of traditional way anyway. So I'm here today to talk to you about more kind of dev-focused activities that improve quality. And as you can see there, I've got a background in development, and although I have these titles, I am still a developer at heart. So, you know, I still do cut code and I still do a lot of development kind of orientated things. I'm going to ask you guys some questions as we go through this because it's boring just me standing here kind of ranting on. So the first thing I'm going to ask you is around code quality. Okay, has anyone ever heard of code quality? Yeah? Okay, you've probably heard the word code and quality. Code quality is. Anyone? No?
Yeah. Yes.
Go on then.
Oh, but nobody see that. I don't say yes.
On the spot.
So code quality refers to the.
I'll
Best way, you finish up the sentence. Your definition's going to be better than mine. You round this off.
Well, it's not way we can look at it, right? What makes a good developer? You guys must be able to answer this. How many of you cut code or have cut code in your course or at home or done anything like that? How many of you here, hands up, who have written some code? Brilliant. Man there who's never written some code.
Never. No,
It's always a first time. So, okay, that's good. So you're all developers, essentially, but what makes a good developer? Maintainability, yeah, very good. Anything else?
Getting your friend to correct it for you.
Yeah, it does. We'll call that a peer review. It's good. It's good. Essentially, there's lots of different types of developers out there, and I've met loads of different types of developers. But primarily, the kind of main ones you see are the kind of developers, the kind of stereotypical image is the developer sitting at their desk, really kind of rattling out code as quickly as they can. And normally that happens because of a very specific reason. Because in the commercial world, there's other people who have a vested interest in code being made. And those people are people like managers, marketing teams, whoever it is you're working with in a business, they're putting pressure on you to get that code out. And the first thing to suffer from that pressure is code quality. So in my mind, a good developer is not just somebody who can get the code out and it works, but somebody who's thinking about things like maintainability, Josh, and thinking about how is this going to kind of last, who's going to see this next, what is this going to affect. So having that big picture view makes a great coder, a great developer. Is it going? Yes, code quality. So this is a picture from one of my kids' books called The Pirate Cruncher. Essentially it's about a bunch of pirates who go looking for a mystical treasure, okay? And they get there and they find out that actually there is treasure there, but under the water there's this huge monster ready to eat them in their ship. Okay, it's a great book, highly recommend it. But it makes a good point. I showed one of my colleagues today, one of our recent grads this, and she said it totally made sense from a code quality perspective. Because most of the time, see this bit up here, the treasure, that's what your customers are using when you're writing code. And it works, they don't care, it works, that's great. But see your development team, if they ever have to touch your code, they're going to find that down there. They're going to find the monster, because 9 times out of 10, you've been under pressure to get it out the door, okay? And by any means possible, get it out the door. And poor code quality is that monster lurking under the surface, waiting to bite you. Okay, does that make sense?
Yeah.
I'm going to tell you why. Well, why does it matter first and foremost? The reason why it matters is because poor code quality increases technical debt. Have any ever heard of that term, technical debt? Technical debt is when basically something's been done so poorly that it actually is going to cost longer to fix it than to actually do it in the first place. Okay? So technical debt is essentially what every business who creates code has. Okay? They may have a small amount of technical debt or a huge amount of technical debt, but essentially no code is perfect ever. So there's always going to be technical debt there. And if you have poor code quality, you're going to have increased technical debt. That's going to take time, it's going to take money to fix. Okay? So by having good code quality, you can reduce that. So here's some code comments, right? I'm going to show this for a reason. Code comments are things that good developers are supposed to do. Okay? You get coding standard documents in development teams that tell you how you should be creating code. And the number one thing, traditionally you always see, is comment your code. Okay? But what that doesn't actually mean is write magic do not touch. What that means is tell somebody what it's doing, so when somebody comes to look at it next time, they can understand it pretty quickly. Okay? Now, this one at the bottom is actually allegedly from a very, very popular operating system that a lot of computers use. It's actually in the source code. So everybody creates comments in this way. But the reality of this is, if you had to go and actually fix something, if you were a developer and there was a bug in the code and you had to go and fix it, that's not going to help you. And technically that person has stood by the coding standards. That is not going to help you. So commenting is important, but it has to be in context and explain what's going on in the code. Okay. Another example of poor code quality is code cloning. Okay. Imagine you've written a bit of code. Okay. Has anyone here ever copied and pasted their own code into another file? Everybody's looking very, very sheepish. Yeah. But it is very common, and it's common for a reason, because there's time constraints. And people think, oh, I've written this before, I can just copy and paste it and reuse it. And that's great, right? It saves you time. Okay? But if you're working on a large application where there's lots of files and people are copying code everywhere, you end up copying that once, twice, 3 times. You end up with copies everywhere of the same code. Okay? That's called code cloning. Okay? What you should be doing is writing it once and reusing it in the same place in a reusable class or something like that. But still, people clone code. And the reason why that's bad is because if somebody comes along because there's a bug in there, they're going to fix that one location. But then what about all these other locations that have just copied and pasted that code? That's bugs sitting around waiting to be fixed. That is real technical debt, and it happens everywhere. Okay? So code quality is about creating high quality code that's maintainable, easy to read and understand, and can be replaced or switched easily. Does that make sense? Cool. Simple as that. So as I mentioned before, you should have coding standards whenever you're doing some development work, but they can be a bit vague. So it's important to use other things to help with that process. The first one, as you very kind of eloquently pointed out, is peer reviews. Most development teams now have a structure of peer review, where when you're checking your code in, somebody else in the team actually checks it for you and actually takes an eye over it and says, yeah, that makes sense, or you could have done that better, or you've done whatever there. It's a great way of finding poor code. It really is. It's very, very time consuming. Okay? Because essentially you're doubling up on your effort. You're getting somebody else to check your code for you. And although it makes your life easier, it doesn't make your life easier. Okay? The other side to it is tooling. So there's lots of tools out there which you can use across different kind of languages. So there's a few I've put up there. There's Visual Studio for .NET. Do we have any .NET developers in the room? Yeah? Cool. Visual Studio has lots of great tools in it for .NET to help check your code automatically. There's SonarCube. Have you ever heard of SonarCube? SonarCube is an open source tool that will analyze code whenever you check it in. So you can actually automate the code process and check everybody's code at once. And it's really good. It'll give you an overview of how good that code quality is. So it's open source, it's free to use. And then there's one called ReSharper, which again is a bit of a .NET tool, but it's another commercial plugin. Again, it's very good at pointing things out. So there's tooling out there as well. So there's ways that you can combat poor code quality. Okay. That's that. You'll be glad to know that's all the quality chat, the lecture on quality. What I'm going to talk about now is continuous integration and how that comes into play. Okay. How many of you here have used a CI tool, continuous integration tool? Cool. What ones have you used? You've used Jenkins because you told us all about it. Hudson, yeah. Any others?
Travis.
Okay. Bamboo, anyone ever used Bamboo?
Atlassian, isn't it?
Yeah, it's an Atlassian one, yeah. It's very, very popular nowadays. And TFS by Microsoft has it built in as well. So it has a build kind of CI tool built into it. And CI tools have come a long way. Does anyone know what they were originally for? Or what they were meant to catch? No? Okay. CI tools were originally developed so that when developers and teams were working on code on their machine and they had dependencies on other files, that they would all be put into one system that would build it and check those dependencies and check those cross links to make sure everything worked. So if you guys over here were working on some code and you guys over here were working on some code and you had different dependencies, you could check it in and the CI would pull up and build it and make sure that everything was great. And it was very, very powerful to do that. It was great. I remember when CI really came to the fore, and it really did make things a lot better, because you always got into a situation where developers would check in code, it would get deployed to somewhere to be tested and built, and it would fall over and nobody would know whose fault it was or who could fix it, more importantly. So the CI tools came along and really helped there. And there's some of the ones down there. Team City's another very popular one. And most of these tools are platform agnostic, which means that it doesn't matter if you're using .NET or Java or Python or whatever. If you're using a build tool, you can automate it through a CI tool. That make sense? Cool. What has changed in the last probably 5 years is that CIs have pivoted to become something else. What they've now become is orchestrators. Okay? And you heard the guys talking earlier on about their testing processes and automating those processes. The CI is the core of that. And what the CI does is it orchestrates the whole magic that's going on behind the scenes to make sure that things are done correctly. So this diagram here, you can see 3 developers checking in their code. So let's say you've got Jenkins as your CI tool, probably the most popular CI tool in the world because it is free. You've got Jenkins, you're using Git. Jenkins will poll Git to see if there's been any changes. If there has been changes, it will take all the code in, build it, and make sure it's okay. But what the CI now does, as well as it can actually delegate tasks to other things to check. So it can send out to something like SonarCube I mentioned there. It can go off and automatically check the code quality. It can go to automated testing, so UI, security, unit testing. It can do all of that. It can run those tests for you, orchestrate those tests. And then from my point of view, probably one of the most coolest things that's happened in recent years is deployment. The CI can orchestrate through things like Docker, Octopus Deploy, Ansible, popping up environments, deploying your code to that environment, deploying that code to production. Okay? And why that's really, really powerful is, in the old days, you used to have basically developers checking in their code at the end of the day. Okay? They'd write a big document for the ops guys to say, we've finished this code now, please deploy it for us. The ops guys would look over it, mark it with a red pen, go back to them, get changes, and it would take 2 to 3 days to get code deployed to an enterprise server for testing, say. Okay? It's a long time to get your testers engaged. Okay? What happens now is that developers can check their code in at night, and overnight the code can be built, tested through all of those systems, done through code quality checks, and actually verified that it's in a good state before it goes anywhere. If it is in a good state, it can be deployed automatically to the server. So instead of 2 or 3 days to get it deployed, the testing team walk in the next morning and can do their functional tests and actually get a test report as well that tells them what's happened, okay, the state of the code. That is hugely powerful. It takes the onus off of developers and testers to make all these manual tasks happen. Okay. Firstly, it's much more efficient than doing it manually. Okay. But secondly, it stops people from cheating. Okay, which can happen. It takes out the human error element. So it's much better to have a predictable, reliable process that has no human interaction, that can just be standardized. Okay. You guys can do this at home, right? This is not enterprise stuff. This is freely available right now. So you guys can go off at home and you can download Jenkins and run it on your laptop, or run on iOS, or run on Windows, Linux. You can run on anything, essentially. Well, maybe not anything, but most things. And SonarQube as well. So if you guys are doing Java, you can go home and do this yourself. If you're doing .NET, you can do this yourself as well. And it's very, very powerful. And to any employer, it's very impressive as well. Okay, because this is the future. This is the way of doing things. Okay. We do this ourselves. So we have in our team, we do a variety of things. So we are the first team of developers in SQS in the world. We have a team of about 10 developers in Belfast, a couple of guys in Dublin. And essentially we do a variety of things for our customers. We can help them build tool chains like this. We can help them with agile processes. We can do merger acquisition health checks. But we also still build code. Okay? And we follow a Devops mentality. So whenever we're building code, we actually follow the practices that we preach. Okay? So it's not just us sitting going, you should do this and this is the proper way to do it. We actually follow these ourselves. So we're building our own applications. We are following this chain. So we use Jenkins. Okay? We use Git as our source code repository. We use SonarQube. We use Selenium. We have our own automation framework as well, which we use. We use Sourced in the Cloud for performance testing. We have our own benchmarking service for security, because we've got security teams. And we use Docker, we use Octopus Deploy, we use Azure, AWS, and we actually deploy these things. So there's a practical sense to this that it's great to talk about it, but it's even more powerful if you can use it and talk about it from experience. Okay? So I highly recommend it. So what does this mean to you guys? Because obviously it's easy for me to stand here and talk about code quality, talk about CI, and talk about all the things that we do and what happens in the world and all this kind of stuff. But what does it actually mean to you and where you are? First and foremost, a good developer builds quality software. Goes without saying, okay? It's a differentiator in the market. If you can go to a potential employer and say, I am not only a good coder, but I produce quality code, and here's how, and here's why, you've got an advantage, okay? Because the people who are interviewing you will be team managers, they'll be senior developers. They won't want to have a huge overhead of kind of managing somebody, so it makes their job easier. So it's a differentiator in the market. Continuous integration is the crux of everything that's going on now with modern development. So you really have to kind of get to hands with it and use it and experience it. So it's again a differentiator. If you can say I've used Jenkins, I build my own code in an automated way, or my team at uni have done this, then it really stands you apart, gives you that practical experience. And there's no reason why you guys cannot use these tools. Okay? These tools are out there. They're easy to use, they're easy to get a hold of. They may seem daunting at the start, but there's loads of advice out there. They have wikis, there's lots of stuff in Stack Overflow, there's lots of people with advice out there to help you get started. So it's really important that you kind of get to grips with them, start using them, and actually know that your code is better for using them. Okay? That's it. Short and sweet. That's it.
Do you have any questions for Gareth?
Yeah.
Yep.
What will the likes of SonarQube look for to say that code's of good quality?
So there are different coding standards out there, okay? And I've been a developer for about over 15 years now, and being kind to myself. But I've seen standards come and go. Okay, but what SonarQube will do is it mixes a lot of standards across languages. It allows you to pick the standards you're interested in. So it will find to-do statements. So if somebody's put to-do statements in code and they've not finished it, it'll pick all those things up. It'll pick up cloned code. It'll pick up a variety of different things. It will also give you a rating on how good your code is. That's a squall rating, which is an industry recognised rating of code quality. But it will also give you a kind of indication of the technical debt of how long it will take you to get your code up to a good shape. Okay? So there's language-specific things in C, for example, C++, are going to be different to C# and Java, but there is a lot of commonality there. Okay? So it'll pick things out like, it'll say, you know, you've got a percentage of a code to comment ratio. It'll tell you how many comments the code lines are in there. It will tell you if you've got monolithic files, which are huge files with just code reaming through them and not breaking things out. It will tell you all that stuff. So it makes you a better developer. Does that answer the question?
Yeah, thanks.
Cool. Any other questions?
Yes.
Yeah.
I suppose